Good day, everyone. This is Sir June. Welcome to my channel. Our lesson for today, class, will be all about factors. So we have here three learning outcomes, class. First is students should know how to find the common factors of two or more numbers. And the second learning outcome is students should know how to find the greatest common factor of two or more numbers. The third and the last the learning outcome, class, is students should know how to find out if number is a common factor of two given numbers. Okay, so now, class, this slide teaches us on how to find common factors and greatest common factor of two numbers. So the two numbers here are the 30 and 42. So the first one, class, as you see here in the first picture, we have factors of 30. So these are 1, 2, 3, 5, 6, 10, 15, and 30. So these are the factors of 30. And we have also here, class, the factors of 42. These are 1, 2, 3, 6, 7, 14, 21, 42. So these are the factors of 42, class. So as you see here also, the factors of 30 and 42, we have encircled here the numbers because the common factors of 30 and 42 are 1, 2, 3, and 6. So we're going now to compare, class, the factors of these two numbers. So as you see here, the common factors 2, 1, 2, 3, and 6, and the greatest common factor there is 6. Okay? So now again, class, the greatest common factor of 30 and 42 is 6. Okay, for this time, class, we're going to find now common factors and greatest common factor of three or four numbers. So a while ago, we just used two numbers to find the GCF. Okay, for now, we're going to um, identify now on how we're going to also find the greatest common factor of three or four numbers. So this one, we have here, find the common factors and greatest common factor of 30, 45, and 60. So of course, class, we're going to list down all the factors of 30, 45, and 60 first. So the first picture here illustrates, class, for the factors of 30. We have here 1, 30, 2 and 15, 3 and 10, 5 and 6. And we have also in the second picture, these are the factors of 45. 1 and 45, 3 and 15, 5 and 9. And the last picture here, as you see on the right side, we have factors of 60. So these are 1, 6, 2 and 30, 3 and 20, 4 and 15, 5 and 5 and 12, 6 and 10. And these are the factors of 60. So note, class, that to identify the common factors here, as you see, the greatest common factor of these three numbers, the 30, 45, and 60, is 15. So look at here in the first picture, there's 15, 15, and 15. So that is the greatest common factor of the 30, 45, and 60. Okay, class, we have now another problem here. Okay, so we can find GCF by writing the prime factorization of numbers. So we can find the GCF, class, actually using the factor 3. So find the greatest common factor of 12, 18, and 21 using factor 3. So the first one, we have here 12. So you can find the factors of 12. So we have here using factor 3. So think, or you have to write the smallest prime factor of 12, so which is 2, and the other factor is 6. If we're going to multiply 2 times 6 equals 12. And now we're going to find the factors of 6. So the factor of 6, the smallest prime factor is 2, and the partner is 3. So if we're going to multiply now, class, 2 times 2 equals 4, times 3 equals 12. The other number is 18. So the smallest prime factor of 18 is 2, and the other number is 9. And now we're going to find the smallest prime factor of 9, which is 3, and the partner of 3 is 3. If we're going to multiply now, 2 times 3 equals 6, and times 3 equals 18. And now here, the other number is 21. So the smallest prime factor of 21, class, is 3, and the other number is 7. Now take note, class, for you to know that it's already the time to stop is you're going to see to it that the last number are the prime numbers already. Okay, so look at this 12. These are 2, 3, 2 and 3 are already small, prime numbers. For 18, 2 and 3 also are small are prime numbers, and for the 21, this 3 and 7 are already prime numbers. Now, when we say prime number class, don't forget that it has only two factors, 1 and itself. Okay, so prime factorization of 12 class, 18 and 21 are 2, 2, 3, 2 times 3 times 3, 3 times 7. That is the factors, okay? And the greatest common factor, as you see here, we're going to compare now the factors. We have here the greatest common factor, as you see here, the 3. So take note that the greatest common factor of 12 and 18, 21 is 3. Okay, so now class, as you see here on the slide, we can also find GCF using continuous division. So earlier class in the previous slide, we used there factor 3. So in this time, we'll be discussing the topic finding the greatest common factor using continuous division. So the numbers here class are 4 already. So these are 20, 60, 120, and 180. So first class, you are going to draw this one. This is the picture of the continuous divisions. As you see here, we already enumerated here the numbers, so 20, 60, 120, 180. So you are going to think class the smallest common prime factor of these four numbers. And we have here 2. So 20 divided by 2 equals 10. 60 divided by 2 equals 30. 120 divided by 2 equals 60. 180 divided by 2 equals 90. Now after that class, since they are still composite numbers, they are not yet prime numbers. So by the way class, I mentioned the composite numbers. Composite numbers have 2 or more factors. So now as you see here, we can find more smallest prime common factor. So we have here 2. So 10 divided by 2 equals 5. 30 divided by 2 equals 15. 60 divided by 2 equals 30. 90 divided by 2 equals 45. Now, next class, the same thing you'll do, actually, class. So still, divide the numbers by their common prime factor. Okay, we have here the 5. So this is the smallest common prime factor of these four numbers here. So 5 divided by 5 equals 1. 15 divided by 15 divided by 5 equals 3. 30 divided by 5 equals 6. And the last number is 45 divided by 5 equals 9. So stop here as there is no common prime factor for this numbers class. So now as you see here, we have the common factors, the 2, and 5. So this one class is typo error. I'm covering it my pointer. So the common factors are the 2 times 2 times 2 times 2 times 5. So if we're going to multiply that one, 2 times 2 equals 4 times 5 equals 20. So take note class, the greatest common factor of 20, 60, 120, and 180 is 20. So again, I have a typo error here. That's 2. So now, again, remember, don't forget class, you have to multiply only the common factors of the numbers. Okay, the common factors are 2, 2, and 5. So just multiply 2 times 2 times 5. So the answer is 20 because 2 times 2, 4. You times that 5. 4 times 5 plus 20. So the greatest common factor of 20, 60, and 120 and 180 is 20. Okay, so we have here class another slide, finding out if a number is a common factor of two given numbers. So question class, is 5 a common factor of 75 and 80? So we'll answer that later class after discussing the solution here. As you see here in the first one, we have here, um, to check class if that number is a factor of a number, we'll be using long method division. So 75 divided by 5. So first one class is you're going to multiply first. 7 divided by 5 equals 1. 1 times 5 equals 5. 7 minus 5 equals 2. Bring down 5. Now, 25 divided by 5 equals 5. 5 times 5 equals 25. 25 minus 25 equals 0. Now, look at here, class. We'll go back on the question now. Is 5 a common factor of 75 and 80? Yes. The answer is yes. Why? Because 75 can be divided by 5 exactly. So 5 is a factor of 75. Okay? So now class, there's another question now. Is 5 a factor of 80? So look at here. So as you see on the other side here, 8 divided by 5 equals 1. 1 times 5 equals 5. 8 minus 5 equals 3. Bring down 0. So 30. 30 divided by 5 is 6. So 6 times 5 equals 30. So 30 minus 30 equals 0. So now the question, is 5 a common factor of 80? Yes, it's yes. So 80 can be divided by 5 exactly. So 5 is a factor of 80. Look at now class. 5 is a common factor of 75 and 80. Why? Because both numbers, both the 5 can be divided by 75 and 80. Now class, we can say also that that is a factor of that if we reach here 0, if there is no remainder. If you end here class, if there is no extra number, meaning to say that number is a factor of the number. So we will to prove here now on the two solutions here, explaining that 5 is a common factor of 75 and 80. Now there's another question. Is 4 a common factor of 96 and 78? First one class we're going to discuss first, 96 divided by 4. So let's start from 9. So 9 divided by 4 equals 2. 2 times 4 equals 8. 9 minus 8 equals 1. Bring down 6. 16 divided by 4 equals 4. 4 times 4 equals 16. So you are going to subtract now. 16 minus 16 equals 0. Now, 96 can be divided by exactly 4. Okay? So 4 now class is a factor of 96. The other side now, we have here 78 divided by 4. So let's start from 7. 7 divided by 4 equals 1. 1 times 4 equals 4. So 7 minus 4 equals 3. Bring down 8. So 38 divided by 4 equals 9. 9 times 4 equals 36. So 38 minus 36 equals 2. Now, question class, is a 4 a factor of 78? The answer is no. Why? Because 78 cannot be divided by 4 exactly. So 4 is not a factor of 8. Simply because there is extra number here. There is remainder. If that number has remainder, meaning to say that number also is not a factor of that number. So 4 is not a common factor of 96 and 78. That's all for today, class. I hope that you learned a lot from my video tutorial about our lesson today. So thank you so much for watching, and stay safe and healthy. God bless everyone. Stay safe. Bye.